Hi, this is David with Creation Crate, and today I want to help you understand how to get started programming your Arduino. In this lesson, you will learn some of the basics, taking information that's coming from the sensors that you'll be hooking up to your Arduino, evaluating the data that you've received, and then helping the computer to make decisions about what part of the code to execute next. The first thing that we'll show you how to do is download and install the Arduino IDE. The IDE is an integrated development environment. Basically, that's just where you type in all of your code, right? Also, you'll know how to set up the main components. There are a couple of components that belong to every program. We'll teach you what they are, how to put them together, and in Arduino, that's called a sketch. Then you'll be able to use those basic commands to create some functions that the computer can execute. The first thing I'd like to talk to you about is the Arduino programming language itself. A programming language, remember, a computer only understands binary, which is a bunch of ones and zeros, kind of like the matrix, right? In order for a human to write a program, if we were just typing in a bunch of ones and zeros, we'd never get anything done. It would take forever. So people develop programming language so that we can type words on the screen that we recognize, but in the background, it's translating that into the ones and zeros that the computer can understand. So you may have a command, for example, go-to is a command in BASIC. Go-to is telling the computer, hey, you need to jump to this other line of code somewhere else in the program. So when I type in go-to, it's translated into the ones and zeros that the computer needs in order to understand what to do next with the information that it has. Arduino is also open source code. It is based on the C and C++ language. Open source means that all of the source code is available to the public. So anybody can make changes and modifications to it, use it for their own purpose or to share with the community. And there is a license agreement that is associated with most open source software. Lots of open source software is like attribution based. So they say, hey, if you use this, we just want you to give us a shout out. So whoever the programmer was that developed it wants you to say that it came from them, and so it doesn't look like you made it yourself, and they get credit for the work that they did. Also, if you develop something, a new function, or you improve it, you share that with the community. You share that back to the community as well. There's lots of different open source licenses, so whenever you're using open source software, it's a good idea just to understand what the basic open source license is for that particular software. Okay, so what we're going to do next is jump over into the computer, and I'm going to show you my screen and walk you through everything that you need to do to get set up, to write your program, and to get it running on your Arduino. Okay, so we are starting here on the Creation Crate website. But what you need to do first to start programming is actually get the Arduino IDE. So what we're going to do is we're going to come over here and type in, here is arduino.cc, which is the Arduino website. And if you type in /en/main/software, plus if you just search it in Google, it should come up if you type in Arduino software. We're going to go right to it this way, and you can see access the online IDE. Now, you can do this in your web browser, so there is a web editor that they've added recently. But we're going to go ahead and install the software so it's on your machine and you can use it even if you don't have an internet connection. The latest version right now is the 1.8.3. If it ever gets upgraded, just use the most current version. And since I'm using Windows right now, I'm going to use the Windows installer. If you are using a Mac or a different operating system, then you'll want to download the one that applies to you. So I'm going to click Windows Installer. Now, this is open source software, so it is free and open for anybody to use, but they still have to maintain it. There are developers that need to work hard at improving the software, giving it new functionality. So if you feel so inclined, you can contribute and donate to Arduino. Right now, I'm just going to show you how to download it. Okay. So this little window pops up here. I click Save File, and I'm going to put that somewhere where I'm going to remember where it is later. In this case, I'm going to leave it in my downloads, and I'm going to just leave the same name here, and I'll be able to find it. Okay. And we can see it's almost finished. Now I can just click on this folder, and I'm using Chrome browser. Your browser may vary, but ultimately all you need to do is go and find the folder that you saved it to. And right here I have Arduino 1.8.3. I've already installed it, but I'm going to show you how to do it anyway. Open up Arduino here. Okay, so what you'll see here is the licensing agreement, and you can read through all this, read to your heart's content. I'm going to click agree. You can check these boxes. I'll go ahead and do the standard install, and I'll leave it in the folder that it wants to put it in, program files, hit install, and then it's going to go ahead and take care of the rest. Okay, so once you see that it says completed, you'll hit close. And then I'm going to close this downloads folder, get that out of the way. We won't need this for right now. And so what you can do is go to your programs. And here I have Arduino. We're going to go ahead and launch that. Okay, so we have successfully installed the Arduino IDE. Okay folks, we are now ready to create our first program or sketch. When you open the Arduino IDE, it will put a default sketch in here for you. What we are going to do, I felt the easiest thing to do would be to go through the code for the first month's project, which is the mood lamp. So before we get started, we're going to want to save this file and give it a new name besides the default. So I hit File, Save As, and then I can name it, in this case, Mood Lamp. Now, you can't have any spaces in your name, so if you do want to break it up, you can use an underscore or a dash, or just run everything together. I click Save. I don't need this default code that they put in here either. We'll talk about that in a little while, but I'm just going to delete this for now. So now I have a completely blank slate. Before we actually get into programming, I want to talk to you about the three parts of a program. So in our case, again, the Arduino sketch has three components. One, the values. So the values we need to define and tell the computer what each of the items that we're going to be using throughout the program are. We'll give it a name, something that we can recognize, and then we can attach a couple of different components to it. We'll talk about that here in just a minute. Next, you have the structure. The structure does not change. So these are parts of the program that would be defined at the beginning, and they won't change throughout the rest of the program. Last are functions. So now we're getting to where we're actually doing something with the code, and sometimes you're going to perform a certain task over and over again. So instead of writing that same code multiple times, you can just create a function, which is one separate discrete piece of the code that does a certain job. Examples of values would be constants and variables, so you can define something that won't change, or you can define something that's going to change throughout the program. A couple examples of structure that we'll talk about is the setup and the loop. And then for functions, you can design a function to read sensors that you've hooked up, like a temperature sensor, and then take that information and evaluate the data that you're getting, and then again tell the program to do something after that. So let's go ahead and break this down for our mood lamp program. So I've already put in the first part of the code. This is going to be where we define the values. So you can see in here there are a couple of functions, and all of this is in light gray. What that is telling us is that this is part of the program that the computer will not read. You can see at the beginning, I know the cursor is kind of in the way, but you see these double slashes. That tells the computer, if you put this double slash here, to ignore this line. This is just for us. This will give us some notes so that we can remember what we're doing, or for the next person behind us that's going to look at our code, they can tell what we're trying to accomplish. Up here, you see just a one slash and an asterisk, but over here you see the asterisk and another slash. Anything in between those two will also be ignored. So if you need to write yourself some long notes, like in this case, then you would use the slash asterisk, and then you can write anything in there and then finish it with an asterisk slash. If you're only going to ask the computer to ignore one line, then just put the // there. Okay, so what we are going to do is define a few variables. So for example, this is pulse speed. We said for the speed that we want the pulse to start with, right? It says the value controls how fast the mood lamp runs. And you can replace this with any whole number. So we've got to give it a number to start with, and then we can change that in other places in the program, which you'll see. We also said this is going to be an integer. So anything that we type in that's an actual command that Arduino recognizes will turn this blue color. So int is built into the development environment, so it recognizes it right away. This is something we made up. We called it pulse speed. Traditionally, you start with a lowercase, and then each additional word after that will be uppercase. So 2 words, you got pulse lowercase and then speed uppercase. Okay, here is the light-dependent resistor pin is going to be 0. So we're using pin 0 for that, and we are telling the computer that, hey, there's a pin there, it's 0, and we are going to call it the LDR pin. So later on, we don't have to reference pin 0. We can just type this in, which will be a little bit easier for us to remember and understand when we're looking at the code. And the same thing here. So the red LED is pin 11, the green is 10, and the blue LED is 9. So we are just defining what we need to let the computer know to start. Also, we have a variable called ambient light. Now, we don't know what the ambient light is. That's going to be information we are receiving from a sensor. So we create a variable to house and store that information as we get it from the sensor to the Arduino. We also have the start of the brightness. We have a float here. A float is a special kind of variable. Basically, it's kind of an envelope or a wrapper for multiple variables. In this case, we're going to call this one RGB, and it's going to be an array of 3 different variables. We're going to store the 0, 1, and 2, which is going to be our red, green, and blue LED light values. And then this common math variable, we are going to use this formula, 180 divided by pi, and you can also see that capital PI has turned blue, so the number for pi is actually part of the development environment, so when I type that in, it already knows what it is. I didn't have to define that. So these are the variables that we are going to use in the program, the values and variables that we will use for the mood lamp. Now, if we go on to the next section, this is going to be the structure that we create. So every sketch needs to start with a setup. This, not really a loop, because it only runs one time. You're going to tell the computer, here are a few things that throughout the program will not change. So we wanted to define the pin mode, and you see this is in red. This is also a command that Arduino already understands. And we're going to say the pin mode for the red LED, which we defined earlier as 0, will be an output pin. So this is a digital pin. We can use it for input or for output. And in this case, we are going to tell the red LED when to turn on and how bright to turn on. So we are telling the computer the red LED, which is pin 11, so if I put an 11 there, it would be the same thing, that it's an output pin, so we're going to send information out to whatever is connected to it. We also have a digital write, and what it is doing is starting, giving this a value to start with. So pin 11, the value for the red LED pin is going to be low. You notice this is also in blue, so this is a command or something that Arduino recognizes. Low essentially means off. It's sending a signal to turn the LED off. So when we get started, we want all 3 LEDs to be off until we run the program and evaluate the ambient light, and then we make a decision on whether we should turn the lights on or off. A couple of things to note here. You have this curly brace. Whenever you start a command like this, whenever you're going to build a function, you start with this curly brace, and then on the other side, when you're all done with that particular section, you're going to end with another curly brace. Now they can be nested so that there can be multiple in here, but you have to remember that wherever you open, you also have to close. Same thing with parentheses. So I opened a parenthesis here, I closed one here. And then also after each line of code, you're going to put a semicolon. That's telling the computer this line is done. I'm moving on to the next command. So it says go find the next command, and it jumps down to here. At this point it says go find the next command. Computer ignores this because we put the / there, and then it's going to look at this digital write command. And this will keep doing this all the way down throughout the code. Next thing we have are functions. So we want the computer to do lots of stuff, and sometimes we need it to do that stuff over and over again. And in fact, as the computer is running, it really is constantly looping through a set of code, making decisions, evaluating information, and doing the things that we are asking it to do. In this case, when you start out, instead of void setup, you're going to put void loop. This tells the computer, go keep on running this stuff over and over again until we turn the machine off. Okay, here we have a for statement. And the for statement is used to repeat a block of statements that are inside of these curly braces right here. So a lot of times it's used for an increment counter and sometimes just any kind of repetitive function. So we have a couple of components. First we have the initialization. So we told it it's the float that we named earlier. We're giving it a 0 value to start with. Then we have a condition. So this will keep going as long as x is less than pi. So it shouldn't ever get over that. And then we have the increment. So it's saying take x and then give it this additional value every single time this loops. And then inside here we have a couple of other commands. We have an absolute number that we're finding using the sign function. And we won't go over this in detail, but basically this is going to vary the brightness of each of the LEDs based on the value that we're giving it. Here we are looking right now at the ambient light. This is the if statement I was talking about earlier. This is where we start to make decisions. So we named a variable ambient light, and it's right here. We don't have any value assigned to that yet. So we're going to do that right here. We're going to say the ambient light variable equals analog read. So I have it located at the analog pin 0. Remember, we also named the LDR pin. LDR pin is 0. So this is your analog input. So it's telling the computer, go to pin 0, read the value that you're getting, and that is going to be ambient light. Then here I'm going to evaluate that information. If ambient light is greater than 600, then anything in this curly braces right here is going to execute. So if that is the case, then we're going to write the red LED value, which is stored in the array RGB 0. And then we're going to write to the green LED, which again we named up here as green LED is pin 10. So we're basically saying write to pin 10 the RGB1 value that's found in the array. Here's the RGB1 value. And remember, this is executing over and over again, so it's constantly changing. And as long as the ambient light is greater than 600, which means there is not a lot of light, then we're going to keep the LEDs on and we're going to vary the brightness. Otherwise, that's the else statement here. So we're going to say if it's greater than 600, do these commands. But if it is less than 600, then, right, that's the else, if else, then we're going to digital write red low. So basically what are we doing? We're turning red off, or pin 11. So I turn pin 11 off, I turn pin 10 off, and then I'm going to turn pin 9 off. So that'll only execute once basically the lights come back on. You have another for statement here. This is calculating the delay. You have if the RGB I is less than 1, then we take this delay with the pulse speed otherwise this delay, otherwise this delay. So that is basically varying the pulse speeds, and the pulse speed actually controls how bright the LED is. We're not really turning the LED brighter and dimmer. What we're actually doing is flashing it faster and slower. It's so fast that our human eye can't see that happening, but instead we recognize it as the light being dim or the light being bright. And this is the last else statement. So as long as none of these things are true, we've got to give it one command. Like it says, it's a fail-safe. It says just don't do anything. Last thing is a delay. So this delay gives the light-dependent resistor time to settle and give accurate readings. So we're just delaying this very briefly so that we get a new value from the light-dependent resistor and then execute all of this code all over again. I hope that helps you understand what we're doing in the mood lamp project and understand some of the basic commands you're going to be writing in your very first program or Arduino Sketch. Good luck with Project 1. If you have any questions, go to www.creationcrate.com. You can go to the Contact Us. You can also go to Facebook Messenger and you can ask us questions directly. I hope this helped you get started. You can find more videos at www.creationcrate.com/classroom. And while you're there, check out our component video series if you want to learn more about the individual components.